So welcome. Thank you for coming to this second DevOps meetup. Today we are going to talk about how to deploy your container into Kubernetes. It's going to be mostly about deploying Docker containers. My name is Jaroslav Živný. Nobody can remember it, so everybody calls me Jerry. I'm a senior software engineer here at Westwing. I'm mostly working with PHP. I'm mostly backend developer, but I'm a member of CAP, Checkout and Payment team. And in the last half of a year, we were responsible for creating an application and putting it into Kubernetes. And it was our first application in the company. Before we start, can I just ask who is working with Kubernetes? Who has some experience with it? Okay, not so many people. So, what are we going to go through today? So first of all, I would like to do some basic of Kubernetes to have some equal knowledge among the people. Then I would like to try to describe some deployment strategies which are relevant for Dockerized applications. And then I have prepared 3 demos of deployment. First of all, some manual deployment, just to have some general idea how the deployment or how the communication with the cluster works. And then I have also prepared some automatized type of deployments. So let's start with the question why we are using the Kubernetes, or why we need such a thing and when we should use it. I think the ideal case for using Kubernetes is when you have a stateless containerized application which doesn't do much thing. So it's like microservice which has one responsibility, let's say. So in this case, if you have application like this, I think it's ideal to put it into Kubernetes. So Kubernetes itself is running containers in a cluster. It takes care about the scheduling of the containers. It takes care that all the containers are running almost all the time, or trying to run them all the time. It solves an inter-networking connection in between the containers for us. And then we can quite easily scale application up and down if we need to do so. So let's dive into basics of Kubernetes first. So I think the basic building block of the Kubernetes is a node. Node is basically a machine. So you can just take whatever machine, for example, this laptop or an Amazon EC2 service, or instance on Google Cloud, or a server in your data warehouse. All those machines together can combine one cluster. Then there are 2 types of nodes, 2 types of these machines. One is master and second one is worker. Master nodes are responsible for operation within the cluster. So they are scheduling the containers within the cluster. There is running also an API, which I'm going to talk about later on. And worker nodes are, in fact, the nodes when our application runs. So usually you have less master nodes, which are just there, and you have it just to, at any given point there is at least one, and worker node you are scaling up and down just for your needs of your applications. Then, so we have these machines. Now we have to talk about pods. So pod, and before I start, let me tell you that a lot of stuff in Kubernetes jargon is just an abstraction on top of something. We are going to talk about abstraction in many layers. So pods is abstraction about above containers. What does it mean? So Kubernetes doesn't run only Dockerized applications. It can run also containerd, cryo, I think Rocket containers, like multiple type of containers. And that's why we need some abstraction above the container itself. It's also the most basic compute unit which we can manage, because you cannot deploy just a container into Kubernetes cluster. You always have to deploy the pod, the whole pod, which is this abstraction. The second reason why there is this abstraction is that we can run multiple containers within one pod. So it's not suggested to do so, but there are some exceptions where it's good practice to do it. For example, if we have two containers which has the same life cycle, for example, this Nginx and PHP FPM, they have to live together. If they are not living together, if one container is going down, the second one cannot operate on its own. So we have to run both containers at the same time. If one dies, we can restart the whole pod there. Yeah, so this is a pod. Now, we have pods, but when we are destroying the pods, we have to have something which is responsible for rescheduling it. So something which is responsible that at all time we are running some amount of containers, some amount of pods. And these things are called controllers. There are multiple types of controllers. We are today going to talk mostly about deployment, or its type deployment. What does it do? It's scheduling the pods, and it manages the desired state. So if we say that we want 3 pods of this application, it will try to run 3 pods of application at all time. So next challenge within the Kubernetes is the networking. So if you are running, for example, just plain Docker containers on your local host, you know you cannot scale it up to 2 because there are conflicts with ports, right? So they cannot run at the same time. So Kubernetes solves this with the pods and with the thing that every pod has assigned one static IP address, static dynamic IP address. So when a pod is created, Kubernetes, the masternode or some processes in masternodes are attaching an IP address to a pod. If you are within the cluster, if you, for example, SSH into whatever server, you can access the pod via this IP address. It's not accessible from the outside, but what is bad here, when the pod crashes and there is created a new one, it gets a new IP address. So you cannot rely on this. So that's the reason why we have services. Service is a network abstraction above pods. So, as I said, when pod dies and there is a created new one, it gets a new IP address, but we need to access it either from the outside or from within the cluster, and we need one single point where we can do it at all time. So, service is an abstraction. It doesn't die until you destroy it, and it has, let's say, the same IP address all the time. It keeps the same IP address. The service is attaching the pods via some so-called labels. We are going to show it later on. How does it actually works? Okay, So then we had a node, a pod, service, and controllers. And so within those blocks, we can already start to create some rich applications, let's say. So let's call this one application that it is just one microservice. As you, for example, see here, there is a microservice for UI, which is accessible from the outside, from the internet by some customers. And then the application itself can connect into APIs, which are running independently on the UI. You can scale it up and down separately. And for example, your microservice can then connect to database and so forth. What is, I think, important here to mention is that you can run also pods without the service. Service is only, as I said also already, it's just a network abstraction. So when we need to access the application via some port, we need service. Otherwise, when there is some background process, for example, some access to database, it processes some data, does something, and it doesn't need to be accessible from the outside of the internet, we don't need a service. The last thing which I would like to mention here in this basics of Kubernetes is namespace. So imagine that you have cluster, you have, for example, 5 nodes, and you are running multiple applications within the cluster. And then you want to list all your pods or all your services you are running. If you do this, you get all services for all applications, and it will be mess. So this is why Kubernetes introduced something called namespaces. And namespaces, according to general best practice, are used for separating projects or separating what's it called? Environments. So, for example, here we see that we are running different. There is a namespace for eShop. If we are listing the services for eShop, we will get only these 2. Then we are running a namespace for checkout. If we are listing the resources for checkout, we are getting only these resources. They are not interfering with each other. The same we can create, for example, eShop production, eShop staging. It will be separated. They will not interfere with each other. Good. So now the main part of this meetup is how to get your code or your container into the Kubernetes. So let's firstly just define our application. It's just simple web server, which should just respond on the root endpoint / with some data. Let's say we just want to show some basic web page. That's it. What we want to do, we want to have a load balancer, which is accessible by our user, and we want to run a container which is replicated 4 times and which is serving the user. So according to load, the load, actually the network load is split among those 4 containers, those 4 pods. So this is our application which we want to put there. So first of all, I think we have to talk about kubectl. If you plan to work with Kubernetes, I think it's really important to get into kubectl. How does it work? What are the possibilities of it? And I think it's one of the most powerful tools, not only for deploying, but also for debugging, for monitoring, or not monitoring, like monitoring, but just like listing the resources which you already deployed. So kubectl, what is it? kubectl is a bash or command line CMD program, CMD application, which you are operating via command line. And what it does, it just connects to API server, which is running in this in Kubernetes in master nodes, and translating the commands we are putting into command line to API calls, and then over the API calls, the Kubernetes creates or responds some resources, or creates resources or responds with some data, let's say. So when you are installing the kubectl, after installation, you have to just configure your cluster or your connection with the cluster via those 3 commands. You have to put there some certificates, names, endpoints, and so on and so forth. But there are just these 3 lines, and then you have access to the Kubernetes cluster. One more thing is that kubectl offers declarative and imperative way how we can communicate with the kubectl or with this program. Imperative means that you are writing down in the CLI, into the bash, what it should do, like explicitly, like kubectl, create a pod with these and these attributes, which I think is good for the first touch. So if you never worked with the Kubernetes, I think it's the best entry point how to get a general knowledge, how does it work, or when I do this, what happens. So I think it's the best. But for, like, in general, when you have a project which you want to put into the cluster, I think it's much better to do with declarative type, which means that we have YAML files where we are specifying our resources in Kubernetes, and those files, those YAML files, we are just submitting into kubectl, which is submitting it then to API, and Kubernetes is creating those defined stuff in Kubernetes afterwards. So this second type, this declarative, this YAML files looks like this. So we were talking about the pods, about the deployment, about the services from the beginning. So here is an example of a deployment manifest. Here is an example of service manifest. First, this one. So here, I think there are 4 important things to notice. First of all, it's a kind deployment. Second of all is replicas 4. So it means the deployment, we are creating the deployment, which then will create 4 pods of this template. And the template has this image. This is the Docker image. And the Docker image is listening on port 80. So these are the most important information from this YAML file. There are some labels. We are going to talk about it later on. And then service, what we are saying here, it's kind of service, and it is type load balancer. There are multiple types, but I don't want to go into these details today. And first of all, it's target port 80, which is this one, and it's opened to the public also on port 80. You can change it, for example, to 433 or something like this. It's just what we like. So when we have such a manifest, we can deploy it into Kubernetes. We can just say to Kubernetes, hey, here is my manifest, here is a state of application as I would like to see it. And please do the stuff. And how we are doing it, we are just kubectl apply -f and then the name of the file, the YAML file. let's see them. If you have any questions during the talk, please just raise your hand if something is not clear. So, let's say. So, I already have installed the kubectl here on my CLI, on my bash. I already configured it. So if I do kubectl cluster info, if I'm not mistaken, I should get some information about my cluster. The information are not important, at least not for today's talk, but just want to show you that we are connected. So first of all, we can list nodes which are running. So let's just take a look how our cluster looks like. So we can do kubectl get nodes, and we see that our cluster is running on 3 nodes. All of them are ready. They are running for some time already. That's good. It's running, by the way, in AWS, just if you are curious. Now, because we are going to create a new application, we need to create a new namespace. As I said, namespaces are good for separating projects. So we can firstly list all namespaces which we have. This one. But let's create menu demo. Oh yeah, create namespace. So we can list it again, and we should see we created a new namespace which is empty. If we now list all pods, for example, from namespace manual demo, you see that there are no pods running right now. So, what I wanted to do, okay. So let's deploy a pod into Kubernetes. So let's say we want to do kubectl run a new pod. So name it a demo. Then there is an image. Let's use this nginx demos/hello, I think. Hello. Then we say that it will be open on port 80, and then we have to put there a start policy. Start never. That should be all. Yeah. So we created our pod. So if we again list, yeah.
So where is this namespace?
It's just an abstraction within the cluster. So
where is this running? Is it on AWS or on
the whole stuff is on AWS. This is on my local host. This bash is on my local host.
Okay.
So I'm connecting from my local host into AWS cluster, but via the kubectl, which is connecting via the API.
So it's like we have to imagine that we run those 3 commands, the setup commands.
Yeah.
Okay.
So for that one, you have to set up, you have to say your credentials, endpoint of the Kubernetes cluster on the AWS and so on and so forth. Okay, so right now we should have deployed our new pod. So we can take a look, kubectl get pod namespace manual demo. No. I should have this. This one I forgot. So what I did wrong is I ran the demo pod, but I didn't specify the namespace. By default, it's used default namespace. So let's do it again. Manual demo. So there is an error, and I just misspelled the image. But we created the pod, if I wouldn't misspell the image name, we would see that there is a status running. Yeah. So there should be just one pod of this image with these attributes, which is there, but I just fucked up the name of the image, and now we see that there is a problem during start. So now you see also when you would like to start with putting something into Kubernetes, you will get some feedback. Like, you are trying to do this, what is happening now? I have this problem, and I can take a look why I have this problem. So this one, this type of putting in information into your bash, it's really not good for automation, as I said already. So we should start to work with these YAML manifests. So if we take a look at our manifest, so I prepared this one. So first of all, it's the same one as I've shown you already. So it's type deployment. It has some image. We are running 4 replicas, and we are opening port 80. And then the rest is irrelevant at this point. I will get to it back afterwards. And then we are creating a service, which is type load balancer and has these ports. So again, if we can then go to the folder and do kubectl, apply file, which is that one what I just shown you. So we are describing all informations there. What I just don't have to forget is specifying namespace. So as we see, we specified deployment, we specified service, they were created, so we can take a look. kubectl get deployment. We have one deployment, which is this controller, which is responsible for spotting up the pods for us. There's desired state 4, and we see that now current state is 4, so everything should run. We can take a look also on the pods itself. We see, this is my first fucked up image, but then we are running this application with the deployment. The deployment controller was starting those 4 pods for us. And now, how we can connect into those pods, we can take a look into services. And you can see that we created a service named observer, type load balancer, and we are getting external IP on which we can access it, hopefully. Let's try it. So let's try to access it. And there is something. If you don't see it. Okay. Come on. It says it works. So now we can take a look. How does it know? How this service knows that it should serve those 4 pods? So let's take a look. So
You have to put here as 3039. Where does it come from?
this one is just some random hash, I think. It's
No, the one you put port.
port.
The service, yeah. 30.
Yeah. Also, it's random. It's a port of node. So the actual machine is exposing this port for this. It's
Little bit of magic.
a little bit outside of this scope, but we can talk out afterwards. Like Okay, the web server is, or this service is running into a node, into the machine, onto machine, and machine itself is exposing this port for us. So in theory, we can have the public IP of the machine. We can access the machine IP address with this port, and we should get the same result as with this, in theory. Okay, so what we wanted to do. So what we wanted to just find out how this knows that it should serve those 4 ports. So instead of kubectl get, we can also do kubectl describe, which will return us more information about the service. So here we see that it has some name, it is in a namespace, blah, blah, blah. But what is important for us is first of all, selectors. So it means that this service is serving the traffic into all pods which has this label, up web server. If we take a look into our YAML file, we can see that this deployment, this pod, has label up web server. We are specifying, we are labeling our resources inside of the cluster, and according to those labels, they are then bounded together. We are the labels and then selectors. So first of all, we are specifying here this deployment, this is the pod, this is the configuration of the pod, and we are saying that this pod has label up web server. And in a service, we are specifying that, okay, select me all pods which has this one. This is what we saw on this describe page. This is the same information. So when it recognizes all the pods which it should serve traffic to, it adds the pods into endpoints. You can see here. So we should have 4 endpoints, which are the endpoints of the pods. So as I said already, every pod has assigned dynamic IP address, which is this one. Then the pod can expose some port, which is that one. It's configured, like once again, where is it? Here. And then via those selectors, we are just bounding those 2 resources together. So the service is looking for the pods with those labels, and then it attached to these endpoints. Hope it's understandable. Ding, ding, ding. So what I get? So we saw the deployment, we saw the pods which are created by the deployment, and we saw the service. And we saw that our application works. So let's delete it, or we can keep it there. Or if you want to delete it, should be just kubectl delete deployment, for example. You can say all in a namespace manual demo. Fuck me. Manual demo. And now if we list it again, get deployment, we should see that there is nothing. Also, when we take a look at pods, because there is no deployment.
The name of the namespace is wrong.
I am. Sorry.
Thank you.
But the deployment, when we deleted it, it also deleted all the pods. I wanted to show one more thing. Maybe I will deploy it again. Sorry for that. kubectl apply -f this one into manual demo. So okay, we have again the same stuff. So if we take a look at, see, so there were, first of all, there were deployment. The controller started pods, which are at this point they were just container creating. Right now they are running, but they are not serving traffic. Take a look right now. We are serving traffic. Now, what happened if I just delete one of the pods? So kubectl delete pod this in namespace manual demo. And I list them again. You can see that the controller already started a new pod for us. So if something bad happens with the pod, it gets restarted, it gets recreated, and the controller, the deployment is responsible for doing this. And it tries to have all the time these 4 instances.
We will give it a try like infinite amount of times.
You can specify this, actually. By default, I think it's infinite times. But what does it do? It can restart here, and from the beginning, it restarts, like there is this Fourier, was it scale or whatever. So it restarts after 1 second, after 10 seconds, and so on and so forth. So it's longer and longer, those intervals.
But those restarts being increased only when something happens inside the container. Right?
Inside the container. If we are deleting it, it will try to schedule it. Also, when we don't have resources, when we don't have enough CPU on our cluster, unfortunately, it cannot create the cluster, the pod for us. In this case, we will see pending. But there are multiple statuses which can be pod be in, and this is also like for different discussion. Then I wanted to show another one more thing. So I want to show you my skills in Golang. So this is just a simple application, simple web server, which has actually 3 endpoints: /ready and health check. No. Or maybe let's talk about it 1 minute later on. So what we just saw once again is the deployment process. So at the beginning there were nothing. Then our kubectl created deployment and load balancer. Then again deployment created those pods. Then the cluster itself makes sure that those pods are healthy. We are going to talk about it right away.
This is the day 1.
No, this is already third day. And when they are healthy, our service or balancer starts to route traffic there. So this is the deployment process, what we just saw. So I was talking about health checks, and they are important because when you have an application, you want to be sure that the application within the container is somehow healthy, it somehow works. You can deploy it, and it can serve traffic. So Kubernetes, how does it do? It specifying liveliness and readiness flow. Liveliness means that the port, the container within the pod is running. It's not ready, still it's not ready for serving the traffic, but it's running and it's healthy. Like there is no fatal error during the start of or not only the start, but during the process of the application, during the running of the application. And then we have this readiness flow, which means when it starts to response with 200, it means that we can start road traffic there. So there are these two types of health checks, let's say. Yep. So this is what I wanted to show you. So the application has the slash which shows this works. Then it has readiness and health check, which are specified down here. So in health check, I did this hack that if I change the environment variables unhealthy into false, it will simulate bad deployment, let's say. So we can try it in theory. So we have our application still running, and now we have to introduce an update with some new cool feature, which unfortunately breaks the whole stuff. So let's say our liveliness probe, then we'll ask, and it will return 500 or 503 or something like this. So what we can do, we can just right away deploy the new version of the application. So you see, service was untouched because we didn't change anything, and while the deployment was configured, we changed something, so it was reconfigured. If we get the pods, we should see. So we see 3 pods are running, 2 pods are not running. This is related to how Kubernetes deploy pods, how does the deployment processes by default. We will take a look at it in the next minutes. Let's see. So, deployment strategies. Kubernetes, there are 2 types of deployment strategies. One is rollout, one is recreate. These are built-in. And then there is a blue-green which is not built-in. We have to simulate it somehow, or we have to install some additional plugin, external plugin, which will do this for us. So, the rollout deployment is the basic one. It's when we use just to write down a deployment, you want to use it, it will use this type of deployment. So what it does, we have version 1 of our application, which is serving public. Now, we are deleting 1 pod, so now the public is served only by 3 pods. We are splitting up a new instance of the second version. We are, when the readiness check and the liveliness check is okay, we are attaching it to the service, and we are serving traffic right now from like 3/4 of our application is served by old version, 1/4 of our customers are served by the new version. And this is happening for every single pod like this. If there is a problem, this is what we saw just a few minutes ago, and there is a problem with liveliness, it will stop this process. So here it will try to get it alive, and if it's not, it will just stuck in this process, or in this state what we saw without this error. So here, once again, this is the same stuff, but it's not animated. This is how our traffic looks like. So this is the version 1, this is the version 2. So we are serving the traffic from the version 1, and then at some point we are starting to serve some amount of customers from the version 2. And they are running side by side for some amount of time, which is quite long. And so what is downside of this is that we are running 2 versions of applications, so we have to, for example, have our database to be compatible with both versions. And when we find out that there is a fuck up at this point, not health check, not readiness check, but something in business side. It's kind of long way to roll back. So we have to do this step all the way back. So it takes some time to get rolled back. Then there is a second type of deployment strategy, which is called recreate. It's not, I think it's not good for front-facing projects, because what it does, we are running first version of the application, then at some point we are running nothing, and then at some point we are spotting up the second version. So we have this dead time here. So we have outage, or how's it called? Yeah. For the application where we are not serving any traffic. So for front-end project, this is not good. On the other side, there are some cases when you have to do this. For example, there is a process, usually it's not for 4 pods, but for example 1 pod, and there is a 1 pod with new version, but they cannot run in multiple instances. So we have to be sure that there is only one instance of something, or does something, for example, in database. And only way how to do it is, okay, we either log database or something, or just firstly turn down the first version, and then start it and second version. So these were 2 basic deployment strategies which are built in Kubernetes. A third one which I would like to talk about is a blue-green deployment. Blue-green deployment is not integrated in Kubernetes. You have to do it either manually, or you have to install some plugin which you install into your cluster, and then it will put there some abstraction above the deployments, and it will do all stuff for you. But, okay, so how the blue-green works. So we have, again, right now, instead of 4 pods, I used 2 because it's better just for visualizing. So we have first version of our application. Now, so traffic is still served for first version of our application. We are starting the second one. We can do some tests, UAT tests against it, just to make sure that everything is correct, everything works. And then, at some point of time, we just decide to switch the traffic.
How do you test the version 2 without the server?
There can be a separate service which just listen to this.
So you need to deploy that manually, or do that you
You can deploy it all the time. So for example, at this point, you can, for example, have 2 services. This will be public service, and this will be test service. Well, to the test service, you are always attaching those second versions of these green versions. And then your UAT tests or your PMs, whoever needs to do some like check of your application, can connect there and check whether everything is fine. Everything is fine. Okay, you are starting this switch, which is this one, and then eventually you are destroying the old application.
So it depends a lot on what you do on the load balancer.
Yeah.
Where you pointing
On the services, how do you register the service? If you want to do it manually, you can, as we shown, there are these selectors and labels, and so you can also, there is a command kubectl patch, and you can run kubectl patch, and you can change the labels. And with this patch, simple patch, you are doing this switch. Yeah, clear? So as we see on this timeline, we are serving the old version of the application, and then at some point of time, we are serving the new application from there on. So it means we are not running 2 versions side by side, which is, I think, good. Then also we can delete those old versions after an hour, for example. So we run the new version application, we are checking the error rate. If there is a spike in error rate, we can just switch back.
So just for a quick note that the deployment is not natively supported by the Kubernetes, so you have to develop your own scripts.
Yep.
That's what we are doing.
Thanks.
Is there anything stopping you from mixing rollout and blue-green? For instance, if you have just like some front-end stuff that doesn't actually affect database and you can just roll it out, right? To see if the users accept it and stuff like that. But if you have something that needs like a database migration, you probably do blue-green, right? So can you mix it?
Yeah, for sure. Like every service or every application, this microservice can be deployed on its own. So as I shown, there were this one application and two applications which were connecting to database. So for example, the front application would be, for example, this one. And then the application which is not connecting to database could be just a rollout. So each one can be done differently. Okay. So let's take a look at some automation via GitLab CI. How many of you are using GitLab and GitLab CI particularly? Okay. So where I wanted to start. So I don't know from which version, but GitLab CI right now has an integration of Kubernetes in its own, like inside. So what does it mean? You just go into this GitLab CI into your project, and you can specify the Kubernetes cluster there. So what you have to specify are, again, those certificates, some endpoints, pretty much the same stuff as you are setting up for the kubectl set for your local host. So you specify the cluster, and then if you are doing kubectl inside of the GitLab CI runner, it knows where to connect. So you don't have to do it manually then. So this is one advantage of this integration. The second one is that when you are going to environments, you should see your application, or maybe not. But if I configure it correctly, I don't know what I fucked up there, but if I configure it correctly, I would see there that there's 4 pods, green, and so on and so forth. So, but what it doesn't do, unfortunately, which I think it's the biggest pain, at least for me, is that it doesn't deploy itself. It doesn't have any procedure how to deploy manifests to Kubernetes. You have to do it on your own inside of the pipeline. So, how we did it, or how we can imagine it. So first of all, those who are working with GitLab are probably familiar with this GitLab CI YAML file. What does it do? It's just a configuration of the pipeline inside of GitLab CI. So GitLab itself, it has a CI integration, some continuous integration tool, and we can use it, and we can define it via this GitLab-CI YAML. I think, or I like it because whenever you push a code, whenever you create, for example, a merge request, the pipeline itself can run, it can test your application, it can check the test coverage, and so on and so forth, and then when you have merge request, it will show some results. If, for example, integration tests for this new branch with this new feature is not passing, you cannot merge because it will fuck up the whole application. So we can then, this is not talk about GitLab CI, so I'd like to just do it briefly. But in general, you are just specifying your steps of your pipeline. So if you take a look at the pipeline, via YAML files. So there are some steps, and the boundings in between each other we are specifying inside of that YAML file. So first of all, we have some build. I'm not building application right now because it takes some time, so I just skipped it. But I have it there just to visualize it. And then what I'm doing, this is the most important, this script, that I'm creating some directories, and then I'm replacing some environment variables within this file, which is in this folder. Why we are doing this is that you can then have quite a dynamic YAML file, let's say. Yeah. So instead of hard coding, for example, image inside, you can use just environment variables which are taken then from the GitLab CI itself. So who never worked with, there is a section where you can specify environment variables for the runners, which will be then exposed during the runtime of the GitLab CI runner, during the running of the pipeline. So what this mstubs does, it just takes those environment variables and it's substituted inside of this file. So it will create a new file with already real values for us, and we are passing it through, we are passing it into the next step. How we are doing it with these artifacts, but again, I don't want to talk about GitLab CI that much. And then there is another step which does the deploy for us. So in this step, we just configured our YAML file, prepared our YAML file. Here, we are just doing kubectl apply and the YAML file, the generate YAML file. And what is also important is this environment, which is specifying which Kubernetes cluster we are using. I'll show you again. So here, where is it? We can specify multiple clusters. You have test, staging, production, different staging, whatever. You can define multiple environment scope. If you are defining this environment inside of this GitLab YAML, it will know that it should deploy there. This is just bounding again. So, okay, so we defined this one. Now, in theory, we can just commit. GitLab CI in git push. And in theory, we should see that there is a pipeline, a new pipeline, which is starting. Now it's preparing the manifest. You can also see what it does do inside. Eventually. Again, please. Cluster is running on AWS. So GitLab is connecting to cluster, again, the same way, probably via API. It's just the magic behind the GitLab. So we are doing just this substitution, and then we are saving it as artifact. In next step, we should deploy it, hopefully successfully. Yeah. So here, increase the size. Here we are doing the same stuff what we did from the local host, from my machine, what we saw. Here we are doing it from the GitLab runner. And what it does, it just runs absolutely the same command as we ran before, and we see that it was created. Now, if we want to take a look how or whether it's deployed or not, first of all we should get kubectl get namespaces, and we should see this namespace is automatically created by GitLab. I didn't delete it, but if I would delete it, it would be spawned like 30 seconds ago, 1 minute ago. You would see it. So if we want to take a look inside, we can do get deployment from this namespace. It looks kind of the same as the manual demo because we are deploying absolutely the same application, just we automatize the stuff. Automatize the whole pipeline. So if somebody merged into master, the application is deployed into, for example, staging cluster. This is how it works. So again, we can take a look at service. And in theory, if we just take this one, again, you see the application that works. So we deployed it in automatized way. Right. Okay, what was next? Okay, I hope I didn't forget anything. So, what I like on kubectl is that it's a flexible solution and there's kind of low entry level knowledge in order to operate it. So you really from the beginner, you can go through it, you can just start to create pods, start to create deployments, whatever, and just see how the cluster responds based on these commands. What I don't like is that the kubectl is quite painful automation, because what I didn't mention is when you are applying this, it's this kubectl apply, it just says that the deployment was created, but we don't know anything about pods. So the pods can crash, pods can have bad image, for example. I don't know, cannot find the image, but this one says you only created. But then you don't know whether your application really works or not. So you need to build an extensive bash script which check whether your application really works or not. Yep.
Yeah, I mean, I was just saying maybe we can add another health check pipeline.
What do you mean?
Health check pipeline.
Health check.
To just
yes, actually there is a readiness actually as health check. See, this is what we are doing. There are again a readiness check and liveness check.
Yeah, but it will be at the end. It will be like a pipeline, so you can just do it yourself.
And the Kubernetes does it itself. So when there is a deployment, the deployment is checking the health checks for us. If you want to, if you mean to hit this health check from the GitLab CI, whether it works, this, in theory, it might work, but in case your application is starting, for example, 2 minutes, you have to wait for 2 minutes and trying whether this one is already up or not.
This value, I think, can be changed initially.
Yeah, but if you have some C# or Java application, then it will take some time to start. In PHP, it should be quite fast. Yes, in theory, what you can do here, wait 30 seconds, then check whether the application is ready.
Like a session pipeline to do like this the bots. If you have like the desired number of bots.
Yeah, exactly. Yeah. This is what I mean. So you are applying this stuff, and then you have to check manually whether whether the desired state is there. Yeah, this is what I meant by this. But you have to do it in some loop, you have to do some bash scripting, so on and so forth. Not mentioning that this application is quite simple. If you have multiple microservices and you want to deploy them in some order, for example, you have to wait for each one differently, and this is a bit painful. So like it's possible for sure, it's possible to do, but we are not doing it because we don't like writing bash script or maintaining the bash script. And it means also that for every project you have to write some customized bash script. So this is just, at least this is my opinion. Maybe somebody likes to write bash script and maintaining bash.
Completely agree to your opinion. I mean, it could be like, I don't know how it works in GitLab, but with Jenkins, for example, the data is broken. And at the end of the pipeline, you can just do CURL curl against your application, and then wait for the status code to be 200, and then stop. I mean,
You can have exactly the same, but you have to do it manually.
no, it is not. It is just a pipeline that can be used.
Yes, but at the end of the script, it doesn't show it. You have to actually implement the program or the curl script. You have to work on the result and retrieve something and have to work on it. So it's not automatically.
You will run it one time and you will not worry about it again. Just one time. The same as you write it in the pipeline.
Yeah, but you have to do it for every single application, trailer to the application.
For the next application.
But then, for example, there are what?
It's on health check, so you have to modify it from the beginning.
Actually, the deployments are not only stuff what you can deploy into Kubernetes via pods. There is something called job. And for example, if you want to run migrations before you are deploying your application, at least we are doing it by jobs.
Like cron job.
Not cron job, just job. And this job also can fail. And then you have to query whether, like, then you would do, like this is some like bit advanced stuff. I didn't want to go inside it. But what you would do is kubectl apply this migration job, let's say. Then you are waiting whether the job, the migration ended up successfully. And after this was done, you can start deployment of the application itself. So then it starts to be more complex. It just depends on your application. If you have really simple application, you can go for this solution. I think it's quite fine. What is also nice, when you are doing this kubectl apply, maybe we can see it now. Then you can see the status of your application here in GitLab right away. It will not alert you. This is a bit downside. There in pipeline it will be green, it's done. But then if you go inside of environments, you will see that they are white, I think. They are not deployed. So this is just the last part of the presentation. So please hold on. So how to go around this problem with custom bash script? We found this tool called Spinnaker. It's developed and maintained by Netflix, and it can be used for deployment of your application, not only to Kubernetes, but into multiple different type of infrastructures. But we are using it for Kubernetes. What is good there is that you have kind of fancy UI where you are creating your pipelines, how your application should be deployed. It's not a CI pipeline. You are not running any tests there, you are not building the image there. You are just deploying the stuff. And the second stuff is that it waits until all resources are healthy, are really deployed and are correctly deployed. So let's just go briefly through this. So what we are doing, instead of applying kubectl apply, we are firing, or first of all, we are taking this manifest, we are uploading it in S3 bucket, and then we are firing the pipeline in Spinnaker. What does it do here? You can see there is just simple pipeline. it can be more difficult. From the beginning, it just downloads the artifacts from S3. Specifying the file. And then in next step, it can deploy. And the deployment works like it waits until all manifest or not all pods. For example, if we are doing the deployment, it waits until all pods are correctly running. If not, it shows some green stuff here, red stuff here. It has some basic built-in monitoring tool, which doesn't work right now because I didn't deploy it. So if we want to just take a look, it would be just defining those two more steps in the GitLab CI pipeline. So, bum, bum, bum. Now we should see somewhere our pipeline. In this preparation, it does pretty much the same. There's some env subst. We are substituting the environment variables. When this is done, we can see deploy Spinnaker. With what it does, it somewhere uploads. There is an AWS S3 copy, so it uploads the stuff into AWS S3, and then we are running we are firing the pipeline here. So you can see the pipeline. It runs. If we take a look in meanwhile into the cluster, what is happening there? kubectl get pods -n. Yep. Watch. Okay, it's already running, but it's 41 seconds. So it waits until everything is okay, and then it marks as succeed. Otherwise, it would be red, and it would yell at you that it's not good. And so this is this basic monitoring tool. You can see that we have 4 pods of this deployment which are running. It's green. Good. So, just quite quick summary. What I like on Spinnaker is that it visualizes the deployment. You can see it really in the nice pipeline, the CI in the UI. It waits for deployments, which I think is a really nice feature. It shows the results of deployments and the basic monitoring. I think it's better to use something else for monitoring at the end. What I don't like is when you start with working with Spinnaker. We tried it here in the company. I had a workshop, and it was kind of painful from the beginning, just to have for all people to have general idea how to work with it, how to configure the stuff, and so on. The UI is quite buggy. It's built on Angular. Maybe it doesn't matter on which technologies it works, but sometimes you just put some information there, click save, and then for some reason all the inputs are empty. So it's kind of buggy. And what I would like to have there is to store secrets somewhere, or at least have some feature to work with secrets, which this doesn't offer. But this is, again, for another topic for another time. So I put some links where you can start working with Kubernetes. I hope it wasn't that much long, and yes, we can do some short Q&A.
Can you show the links?
Hmm?
Can you show the links?
Yeah, I will put the slides into description. Yeah.
Are you hosting Spinnaker on AWS or are you using?
It's again, it can run in Kubernetes actually. So we are deploying it in Kubernetes into different cluster than staging or production. So there is different cluster which is running Spinnaker, which is then deploying to staging, for example. First.
Can you, with Spinnaker, let's say you have like a shit ton of customers and they all have their own Kubernetes cluster where you deploy your application. Can you just tell Spinnaker to deploy, like, let's say Jenkins builds it and everything, or perhaps CI, can you tell Spinnaker to just deploy the new version on all the clusters, or is it per cluster for a job? Would be kind of silly if you couldn't.
I think it's per cluster. You can define it. We also did it actually. So you can take a look here in deployment. You are setting up the account where you are deploying to. Here it's just a basic where is the drop down, but you can do a variable from it, and you can parameterize it when you are starting the pipeline. So then you can say Spinnaker start pipeline with this parameter, and then you can do it 10 times, and it will start 10 pipelines, and each of them will be to different cluster, for example.
Is there any restrictions in the YAML file that Spinnaker can deploy and monitor the, for example, if you use Spark operator or something like that, can it actually watch that all the workers are launched and running, or?
Everything what we worked with was properly monitored or properly deployed. There were no flaws so far. We also didn't try all the features actually of Kubernetes when we were assembling. Yeah.
How expensive is it to run it on AWS?
Ooh, this is not a question for you. Sorry.
To run it or run your cluster? Running cluster, which is...
It depends, I think, on your workload.
Yeah, it depends on your workload, definitely. That which is inside of how many workload massive count that you need or how many load balancing that you need. But for the Spinnaker workload, I think we are just like we are treating the Spinnaker like 1,000 times a day maximum, and that is going to cost us like $1,000 per moment. So it's not really big money. But also we have different apps that run in the same cluster with Spinnaker, so we also increase a bit. But I think one workload and one maximum is really enough for us to run the Spinnaker. Do you have the one reserve with them? For Spinnaker? Unfortunately, there is one. We were expecting, I don't remember the name, but there is one software service for the Spinnaker that you have to pay. In fact, the Spinnaker is definitely free, but there is a community that is providing you help as Spinnaker as an enterprise service. So they are supporting, they are installing, they are managing, or whatever, so there is little. It's, what was the name? I don't remember, sorry, but I will share it in the Meetup page. Very fine. And what is it difficult to set up? For Spinnaker? Yeah, unfortunately, it's really painful to set it up. For the Kubernetes side, it is a bit easier, but if you want to provision for like an on-prem server or an EC2 server, it is getting a bit painful. There are two things you should care about. There's one of Halia, that is the configuration manager server of the Spinnaker, and the other thing is Spinnaker. So if you are not setting up the Spinnaker itself, you are just setting up a Halia, and you are constantly parameter Halia, and you're just saying that, okay, Halia, deploy it, and Halia is creating a cluster, provision the Spinnaker. But the thing is hard to configure Halia itself.
Where you watch some?
I haven't deployed the Spinnaker. If you want to talk about deployment of the Spinnaker, you have to talk to me about it.
So are you like just, if you're running several Kubernetes clusters, right? Probably like one for production, one for development, and so on. Do you have something to manage the clusters? Like something on top of a cluster to manage several clusters? Is there like a tool?
Like an administrator, maybe?
Yeah, for clusters itself, basically. So one developer.
No, we are using something like for monitoring. We are using Prometheus, or just monitoring how CPU on the nodes itself works, performing, and so on. Whether there is some issue or not. But I think for the like cluster itself, for managing, we are using the kubectl.
Yeah, we have unpacked repository to manage like RBAC permissions or I don't know, some deployment, some services that really depends on the cluster itself and like not based application perspective but cluster perspective. So, Jerry, can you show the applications SRG pipelines that we are also using?
So we are using
managing the cluster itself for the staging and production.
How is it called?
SRG.
Just SRG.
So the pipelines, then you can see that here we have different pipelines to deploy so many things like Ambassador, Calico coordinates, and like Teams RBAC deployments. So if someone wants to create a new team and he wants to deploy some, I don't know, some application, we have to create an RBAC role for this team, and we are managing this RBAC management in this team as well. But in the basic way, we have one package to storing all these configurations of the cluster itself. And we are sending to Git, triggering these pipelines and running the pipeline for and staging and production cluster itself.
So I will add, these all tools are something on top of Kubernetes usually. There are some ingresses, whatever, and these are tools which we are deploying on our own into cluster, which are then helping us with the managing of our other services. Yeah.
But you don't have something like, I don't know, Ansible Tower or something comparable to Ansible Tower where you manage all your entire fleet of clusters.
So there's a protocol with QCDX. This is to switch between clusters.
You're talking about the switching clusters?
Or just managing
Managing, we are using mainly just the QPCPL and
okay, we don't have that for Mac, basically. It's much easier to use that for the Mac, but for the Windows, yeah, QCDX is much better.
QPCS, I think what it does only is just switching in between the clusters. So, as I shown you, we have this kubectl. You are setting up the clusters there with these credentials, but you can set up the credentials for multiple clusters for your local host. So you can connect to staging, test, production, whatever. And then you can switch in between those contexts.
Instead of using kube control set context, you will just set kubectx. And there is also a tool called kubenx. So switching.
Of course.
So you have like a bunch of clusters, right? How do you, if a new employee joins the DevOps team, he has to do operations on like your 137 clusters. Do you just go into every cluster and make credentials for him, or like that's what I mean by managing, like the way to see all the clusters, maybe make users. And
for this, we have something on the top of it. I'm not part of the DevOps.
Those things like DevOps team dedicated to the whole stuff we have in cloud. We have like usually somebody responsible for some deployments inside of the team. So like every one of us kind of DevOps, you know, because nowadays we deploy our stuff for ourselves.
if you get a new guy, you just have to make credentials on every single.
There is a project
case by case.
Okay.
which does this for us actually. So it deploys this AWS these roles, these Kubernetes roles and this stuff into Kubernetes, and then it creates the account for us quite easily.
Yeah, basically we use in company this fund logging approach, so we share application-based access roles through.
So in fact, if you guys want that, you can ask a question about the application deployment base to the Jerry. And if you want also, I can also give a super short summary about our Kubernetes cluster design. So how we install it and how we managing the RBAC or whatever things. So that's much better, I think.
So there are better people to ask. Yeah.
So I have to out myself. I'm from Hitler, so I'm glad to see the stuff you're doing here. The thing is, I try to understand a little bit why you're not using Helm and why you're not using the auto-deployment stuff. Because we are currently doing that a lot. So I try to understand a little bit better where your challenges were, so I can maybe take that back.
We are using it. We are using Helm. I just didn't want to introduce it here because it's kind of complex stuff just to understand, and I would just spend another 15 minutes only just by explaining how the helm works. But in production or in real project we are using helm.
So you're using that kind of for the deployment stuff. And did you connect the auto deployment to use Helm as well, or are you not using the auto deployment stuff of GitLab at all? And do that with connected?
We are doing this right now.
Okay, so you're not using the auto deployment. Maybe you can chat on why that is effective the case. I try to understand that. I know we are doing a lot of things in that area.
Okay, yeah, for sure.
So since this one with Docker and containers, I heard many times that each container should do one thing and one thing only. But it's quite common to see containers that contain Nginx, PHP, FPM inside, and so on. And then in the presentation, I also see the pods having the same thing, separating into the containers. So would you say that it kind of solves the problem and makes Docker or containers in the right way using pods?
So in Docker, there is this problem that you should have one application which has PID1 and which runs all the time. When it dies, your container dies, right? If you are running Nginx and PHP FPM together, you have to have some manager on top of it which has this PID1 and which is taking care about this. So either you have to do it like this, or you have to separate it and using it within one pod. Because, as I said, when one container dies, when Nginx dies, PHP FPM cannot do anything on its own. So it has to run together. So then the Kubernetes will restart the whole pod, both containers together. Also, they are seeing each other in local hosts, they are sharing the pods, so the connection there should be quite fine. Problems.
Question. Could you go to the slide with the deployments?
Which one? Just tell me stop.
This one, the liquid. Where it's already switched here. I'm wondering how it's managed. Let's say that this service is a service that is running long-running tasks. Some kind of cron server, or let's say it's running something that's usually 10, 20 minutes, it finishes processing some queue, and then it finishes and immediately checks again the queue and starts.
Okay.
So is there some kind of shutdown procedure that is really like ensuring that we don't cut the job in the middle? Or is there something like configuration in the manifest file or something like that stops, really says shut down, but in a nice way?
I'm not sure. But what we are using, instead of running just the pod, with just some cron tab or something, there is something called cron job inside of the Kubernetes itself. So you can define in Kubernetes that you want to have a cron job, which will then spot a pod each 20 minutes, and it will do some work there.
And when the job finishes, then this thing will happen.
There is a different deployment. There is no deployment strategies. Deployment strategies are for deployments and for a replica set. Yeah. So if you are just specifying cron jobs, there is pretty much the same time string for when it runs. But what it does, it just spot one pod, it does the job, then it dies.
Okay. So
and then in 20 minutes, for example, if you spot another pod, it does some job and it dies.
Also,
So I think it's a more ideal, more elegant way how to stop this. Yeah.
With the rolling deployment strategy, is there an impact on the capacity? So when an instance is being taken out and
Yeah.
you advise to scale up manually before, or?
You can specify how many pods can be taken down. By default, it's I think 25%. So if you have not 4, but you have, for example, 10 pods, by default it can take 2.5. two pods down. Then it recreates, starts a new one, attach it into a cluster, and so on and so forth. You can specify the number or in percentage or also in number, like in definite numbers, how many pods can be destroyed during the deployment.
Okay.
So for example, if you have 10 of them, you can specify take down only one at a time.
Okay, because the ELBs on Amazon, they also support additional batches, and I was wondering if the config of Kubernetes does support it. So to create the additional batch, and then to deploy on the additional batch, and then to replace.
I think by default not, or I haven't seen it. For sure you can do it manually. In fact, like one of the processes how to deploy this blue-green is like this one. One of the types is that you are creating new pods, like for example 2 pods. Let's talk about. Sorry. So you are running the old application, then you are starting 2 pods of the new application, and if everything is fine, then you are starting to roll out this one. So then you have these 2 up to add on everything else, and then it should be fine, or whatever, how many you want. And then at the end of the deployment, you can create these additional pods. But you have to do it manually. At least I didn't see any. Maybe it's possible, but there are so many options. Yeah.
Thanks.
Any other question?
Can Spinnaker handle blue-green deployments for you?
Yeah. Oh, not by default, not just like you would define blue-green in some dropdown. You have to do it kind of manually, but it's in UI. So you specify one block which will deploy the new version of your application, but it will not attach those pods into the service. So in Spinnaker you can do like it's this one. You are starting the new pods via Spinnaker. You can specify one building step as this, and then another building step would be switching the traffic. So like this. So it's not automatic, it's kind of some manual work, but it's possible. If no other questions, thank you for attending and for staying so long.